All right, so try evaluating at x equals 0. I do get 0 over 0. So yet another one where I'm going to multiply by the conjugate. So you're getting comfortable with recognizing that that's a useful thing to do. Limit as x goes to 0. So multiplying the numerator out, it's difference of squares. So I'll get x squared plus 100 minus 100. And then on the denominator, again, do not multiply it out. Cancel the 100s. So I'll get x squared over x squared plus 100 plus 10. Now I can see the x squareds cancel, so I'm left with a 1 in the numerator. So to finish it off, plug in x equals 0. So I get 1 over, so this gives me root 100, 10 plus 10, so 1/20. All right, ooh, this looks a little challenging. So it is 0 over 0, so let's multiply to get rid of the fraction. So the least common denominator would be 3 times root x, right? 3 times root x. So limit as x goes to 9. So multiplying, canceling as I go, I'll get 3 minus root x all over x minus 9 times 3 root x. Okay, so these don't cancel, right? These is subtraction, this is multiplying, that doesn't cancel, so I've got to think a second. I know. Let's factor a negative out of the numerator. Maybe you'll see it. I see it, but maybe I'll help you see it. Oops, there we go. X minus 9, 3 root x. So after factoring the negative out, do you see that this can be broken up in that clever difference of squares? So if I do that, that negative stays up on the top. This clever difference of squares is root x minus 3, root x plus 3, and then times of 3 root x. All right, so these cancel. So now I'm ready to plug in x equal 9. So I get a negative 1 in the numerator. So plugging in x equal 9, I'll get a 3 plus a 3 for that term. And then I'll have a 3 times a root 3, which is a 3 times a 3. So negative 1, 6, 6 times 9, 54. And notice there's no limits anywhere here after I plugged in the number, right? No limits in that place. And I've written limits every single time. So if you have questions, please ask of how to write things up. It's important. All right, so now I'm going to talk about the squeeze theorem. And I've got one example that's already written out and one example that we'll do together. All right, so if I have 3 functions, so let me give you a picture of what's going on. So if I have this f of x, so I'll put f of x in blue. There's my f of x. And then I've got a g of x function. There's my g of x. And that's the green one. And I've got an h of x function. There's my h of x. Okay, and this is all happening near the function a. So if I've got these 3 stacked, where this one's lower than this one and this one's the highest one, and near a, except possibly at a, and if I take the limit as x goes towards a of the f and the h, the one on the very top, that's what the h is, and the one on the very bottom, and they both have a limit of L, then the one squeezed in between must have a limit of L as well. All right, you'll always be told to prove using the squeeze theorem. The questions will come always that, and they'll be told what the answer is. You just get to show the proof of it, which means you need to write out quite a bit, a little math paragraph. So you don't have to write these words, but you would start with a true fact, and this is a true fact. Since I see a cosine function inside here, I would squeeze cosine between -1 and 1, because that's a true fact. Then if I change the angle to pi over x that's in the problem, that doesn't change it either. That keeps it between -1 and 1. Then the next step would be to multiply this whole line through by x squared. So x squared in each case. All right, so now that is this first criteria. I've got 3 functions stacked on in this inequality. And now I want to take the limit of the 2 outside ones. So then I take the limit of this -x squared, and I take the limit of this x squared. And I take the limit as x goes to 0, which was given in the problem. Can I plug in x equals 0? I can. I do. I get 0. Can I plug in x equals 0? I can. I get 0. Since these 2 limits are 0, therefore the limit of the one in the middle is 0 by the squeeze theorem. Okay, so it'll feel kind of contrived. It's going to be very much like the one we just did. So here's my problem. It'll say prove, it'll say using the squeeze theorem. So I'm going to start with the true fact, and I'm going to see that sine of x is the function. You're going to get very similar problems to ones that I present, so you can all kind of just follow the pattern. The next thing I'm going to say is I know that sine of 3 over x that is given in the problem keeps it between 1 and -1. Then I'm going to multiply through by x to the 4th, because that's what's in this problem. Multiply through by x to the 4th. Okay, so that's the first criteria. I've got the 3 functions in an inequality statement. Next step, I'm going to take the limit as x goes towards 0 of -x to the 4th, and I'm going to take the limit as x goes towards 0 of x to the 4th, because I'm going to take the limit of these 2 on the ends. That's kind of the second criteria. I asked myself, can I plug in 0? I can. I get 0. Can I plug in x equals 0? I can. I get 0. So since the limit of these 2 is 0, therefore, and 3 dots is a nice way to say therefore, the limit of the one in the middle, x to the 4th, sine of 3 over x is 0 also, and you just need to say by squeeze theorem, the theorem that you're using. Okay, one last one with squeeze theorem. You'll be told to use it. So here they're asking you to find something, and they're giving you the whole inequality. They're giving you that stacked inequality with the 3 functions. So the f of x is already in the middle. So there's much less work to do. So the function is in the middle already. So that's the first, like this one here, that's the first criteria is satisfied. All right, so what's the second criteria? I need to take the limit of the 2 outside functions, x squared minus x plus 3. And where am I taking the limit towards? Wherever it's saying here, so limit is x goes towards 1. So if I plug 1 into this function, I get 3. If I plug 1 into here, I get 1 minus 1 plus 3, I get 3. So therefore, the limit as x goes towards 1 of f of x is 1 also by the squeeze theorem.